Hi, in this video we will talk about unit testing. The good thing with Ligo is you don't have to learn another language to do unit testing. The unit tests are also written in Ligo, and you can import the source code in Ligo too. So the Ligo command to run test is Ligo run test, and you pass and you give the full path to your test file. When you run this command, Ligo will inject automatically the testing framework library. And then you can use it inside of your unit test file. It will be useful to create a blockchain context, deploy a smart contract, and send external transactions. If you want to have a look on this library, you can refer to the Ligo documentation. So if you have a look on the test section you have here, you have access to all the functions that we will see just a part of it. Okay, that's quite a few of functions. So generally what we do, we don't mix unit testing and your source file. So your source file, you don't touch it. It remains on its file, but you create a new file for your unit test. So let's have a look on the classic counter smart contract code. So we have here a basic smart contract that we know. I can compile this contract. And now you can create a separated unit test. So the first line, I need to import my source code. Then I will need to deploy this smart contract. So I will use the test library originate function. So just be careful, because on the next version of the test framework, you will use the next library here. That's for the transition. So you can use the old version, but you have to be careful of what you are passing in parameters. Sometimes there are some changes. So let's stick to the last version of the test framework here. What is important is that I use originate for contract. I'm passing here as a namespace of my contract with the contract of expression here that will convert my namespace into a contract. I'm passing initial storage and the quantity of days, so it's 0 here. What I do just after, I can do my first assertion, and I can look on the result. So that after deploying my contract here, I have what I expect on the storage. So to get the storage value here, you use get storage function. By convention, if you want your test to be in the test report, you have to use a function that starts with test. So you need to prefix with test any function you want to be part of the test suite. Here I use the assert function from the test framework. So here is a shortcut. I don't use test dot, but it is the same as test.assert. And you can do assertion. So you test that something has to succeed here. And you can use also a message in case there is an error. So here, for example, you can say, okay, assert with error. I do my test here to true. And if there is a problem, I pass a second parameter that is the error message. It's important to notice that more tests you have, better will be the coverage. And also that if you have an error at one specific test, the test execution will stop. So you will stop at the first error found in the function you have declared with prefixed with test. Okay, so after deploying contract, I can try to send the first transaction. So I can use the transfer operation here. I pass the address of the contract. The parameter here, I want to increment by 1, and here whatever it is, could be 0, 2. And then I can use also log to log what is the result of this transfer. That will be the status of the transaction here. You have noticed that I can log in the unit test. This is something that is not possible when you deploy your smart contract on a node on the network, because you don't know who will be the baker that will execute the transaction, and you don't have access to the log of the server of this baker. And this is quite useful if you want to debug your smart contract using some logging. You can also fine-tune the context of your blockchain. So here behind the hood is a kind of a context simulated Tezos blockchain, but you can also have a way to change some parameters. So if you use reset, you can reset the state. You can say how many accounts you want to have already created in this blockchain. And also you can give some balance to these tokens. You can extract the accounts you have created. So here I'm selecting the first account from my context, and I'm calling it a baker, for example. I can extract the second account, and I will call it the sender, so it will be the user. I can use some log to check that the sender has some money. And I can define my baker as the baker of this blockchain. So now that I have a user, that I have a force, I can pass it as parameter with my function here. And then I can use it to specify it here, so I will be sure that here who is deploying the contract or sending a transaction, I'm setting the source of it. Finally, here I have to pass the parameter that is my sender for the test. So I can change like these different icons between Alice, Bob, etc. Having different balances or role in your smart contract. There is also a way to control time. So for example, if I want to check here what is the time before I deploy my contract and time after I deploy this contract, I can display that, and to check how many blocks it takes to deploy a contract, playing with time going forward. So remember that we have, depending on the protocol you use, but a 15-second block. With the last version of Tezos, you will have maybe 8 seconds. So you can check also this with logging to be sure that you are in a correct minimum block time. If I want to go forward in time, so I can run this unit test. So here, I know that I have a block time of 15 seconds, for example, to deploy my contract. Okay, here I have the result of the transaction. Here is here the result of the transaction after I send the transaction of transfer. Here I have the balance of the sender, etc. And I can also move in time. So if I want to move here a bit in time, I can use bake until one cycle here. In my case, is to have scenarios based on time. If your smart contract use this feature. So if I relaunch here the test, I will see that I have a cycle of 8.5 minutes here. Okay, so just before ending this video, I would like to say there are two other ways to test Ligo, but it's more for debugging than unit testing. Is to use Ligo interpret. You pass an expression to be executed and a reference to a source file. If you want to have a look at this function, you have it here. So you can interpret very quickly an expression in Ligo. The second way to debug very quickly is to use Ligo dry run. So Ligo joy run will simulate a code of a transaction to a Tezos node. So you pass the source file, parameter, and storage expression, and it will return you like a simulated transaction. But for me, these two ways are more debugging than real unit testing. So for real unit testing, I encourage you to use a testing framework. Thank you for watching this video, and see you next time.